The Cobb-Douglas production function is P equals to A times L to the power of alpha times K to the power of beta, where A, alpha, and beta are greater than 0, they're constants, and alpha plus beta equals to 1. Here, L is the total number of person hours worked per year. K is the real value of all physical capital. A is the total factor productivity, and alpha and beta are the output elasticities of labor and capital, respectively. Show that L times the partial derivative of P with respect to L plus the K times the partial derivative of P with respect to K equals to P. So here we'll start with the left-hand side. First, we'll actually look at what is the partial derivative of P with respect to L and P with respect to K. What does that look like first? Okay, so partial derivative of P with respect to L, this is equal to, remember that A, alpha, and beta are constants. And since we're taking the derivative with respect to L, treat everything else like a constant. So treat K like a constant. So we have alpha, I'm going to bring the alpha down, and then we have A, L to the alpha minus 1, K, beta. And so this is just using the power rule for derivatives. And then the other one we have is partial derivative of P with respect to K. So this is treat everything like a constant except for the variable K. So I'm going to bring the beta down. Then we have A, L, alpha, K to the beta minus 1. And this is the power rule. Okay, and then we're going to use this and plug it into the left-hand side. And then try to get the right-hand side. Okay, so for the left-hand side, we have L times partial derivative of P over partial derivative, over L with respect to L plus K times partial derivative of P with respect to K. Okay, so this is equal to, let's plug everything in, L. So what I'm doing is I'm going to plug in this is equal to this, right? And then the other one I'm going to do is this thing is equal to this, okay? So we have partial derivative of P with respect to L, that's just alpha A, L, alpha minus 1, K to the power of beta, plus K times partial derivative of P with respect to K, so this is just beta, alpha, L to the alpha, K, beta minus 1, okay? So this part is this thing, this is this thing. Now we can expand and simplify. So here what we did was we just plug in. That's what we did earlier. Now we're going to expand and simplify, or just simplify really. Notice that there's two L's here, and when you multiply the L's, really you just add the exponents. So this is like to the power of 1. So here, alpha minus 1 plus 1 would just be alpha. So we have alpha A, L to the alpha minus 1 plus 1, right? K beta plus your beta. And then I'm going to do the same thing for here. You see there's two K's here. And when you multiply them, you just add the exponents. So think of this as K to the power of 1 and then beta plus 1. So when we add the exponents, we have L alpha K beta minus 1 plus 1. And then we can cancel these out eventually. Okay, so what do we do there? Here we just kind of we rewrite L and L times L to the alpha minus 1 equals to L to the alpha minus 1 plus 1. And we rewrote K times K to the beta minus 1 equals to K to the beta minus 1 plus 1. And the next step, we're just going to simplify. So we're going to simplify. Remember, we were going to cancel these out. So next we have alpha A times L to the alpha K beta plus beta A times L to the alpha K to the beta, right? And here we just simplify. Okay, and then notice that we have this and this. This is the same, right? Actually, we notice that this is equal to P. This is also equal to P. So we can substitute that in. So I'm going to write that this is equal to alpha P plus beta P, right? So this is since P equals to A L alpha K beta, right? So we can factor that. And then the next part we're going to do is we can factor the P, right? So we have alpha plus beta times P. So all I did there was I factored P. And in the beginning of the question, they told us that alpha plus beta is 1, right? So if alpha plus beta is 1, then we have 1 times P, right? So this is since alpha plus beta equals to 1. And then we're just going to simplify what's 1 times P. Well, 1 times P is just P, right? And well, now we get the right-hand side. So we see that, okay, left-hand side equals to right-hand side. And maybe I'll just write that a little bit neater. So I'll say, therefore, we've shown, what did we show? We wanted to show that L, partial derivative of P with respect to L plus K, partial derivative of P with respect to K equals to P. And that's all.